So we're going to take a look at comparing with word problems. So again, we're going to make a tab, entitle it Word Problems, cut to the margin, cut all the way down. Pause the video and copy these down. That's the bottom left. That's, I forgot to show you the exponential. Alright, so first thing you do is make a table, you find the pattern, you write the equation and determine what function is. So you have $50, okay, for membership. So I'm going to say number of times that they go to the gym, and then that's going to be dollars. They pay, without going to the gym, they're going to have to pay $50 just to become a member. Then the first time they go to the gym, they're going to have to pay plus $3, because every time they go to the gym is $3 more. Second time, they're going to have to pay another $3. So you can see it totals out the way it's totaling out. Alright, so what is this? This is a linear equation. Why? Because the first difference is growing at a constant rate. Okay, so this is a linear function. Alright, what's the equation for a linear function? Y equals mx plus b. So you want to write that down. And you know, there's two ways you could do this. You could do this by patterns. You could do this by equations. I'm going to do it by equations. M is the slope, or the way it's constantly growing. And then b is the y-intercept, where x is equal to 0. So that's going to be y equals the slope, which is 3x, and b is going to be 50, where x is equal to 0. That's pretty much it. All right, let's take a look at another problem. So there are 20,000 hours in the world. Every decade, the number of the hours is halved. Okay, so time is always x, so we're going to put decade as x and number of hours as y. All right, so when we first start at 0, when we haven't first started a decade, there's going to be 20,000 hours. And then there's going to be a listening check. I'm going to put the number 10 on the second one, but you're going to put the number 1 because it's already in decades, so you're not going to say 10 decades. It's going to be 1 decade. And what that is, you're going to divide it by 2, which is the same thing as multiplying by 1/2. Listening check again, you're going to put the number 2, not 20. And again, what are you doing? You're multiplying by 1/2. Because dividing by 2 is the same as multiplying by 1/2. So you're going to keep going like that. Third decade, you're going to have 2,500. It's always multiplying. And again, this is not what you copied down in the beginning. Please do not copy down what I have here. I'm going to change it. All right, let's take a look at the equation. So it's an exponential function because you're multiplying. So you're either halving, tripling, doubling, etc. And the equation is y equals abx. And a is your initial, what you start off with. B is how the ratio how it's growing. And x is time. And so let's fill in the number. Y equals, what's your initial? Your initial is 20,000, where x is equal to 0. And then how is it growing? By multiplying by 1/2, and x is the time. And you can check that to make sure you're fine by plugging in any value in the table. So x is what, 2, and it should give you 5,000. Or you can go y equals, plug in the equation, hit second table, and just compare your table and make sure it's the same. You can see that it's the same. Okay, so you can always check the answer once you write your equation. Alright, let's take a look at another one. Julie gets a prepaid cell phone. Initially, she has a $40 balance on the phone. So initially, when she first starts at 0, she has $40. So we're going to do number of minutes and the balance that she has on the phone. So she has $40 and she hasn't talked at all. Every time she speaks, we're going to subtract 0.15. So at first minute, we're going to subtract 0.15 because that's how much it costs to speak. So you do 40 minus 0.15, you get 39.85. The second minute, you're going to subtract another, because every minute is going to cost 0.15. You're going to subtract another 0.15, and then you'll get how much money is left on the phone after the second minute, which is 39.7. And so forth. So just keep subtracting keep subtracting 0.15. Alright, so what is this? How is it changing? It's the first difference is constant. So what does this mean? This is a linear equation. So it's y equals mx plus b, where m is how it's changing, which is negative 0.15. And b is where it intercepts the y-axis, or where it starts, which is when x is equal to 0, so plus 40. Alright, so they want it in terms of f of x, and f of x is another way of saying y, so I'm just going to write it again with f of x. And then I'm going to answer the question. So it says find the value of f of 100. So f of 100, you'll notice that 100 is where the x is. See that? So that means everywhere you see x in the problem, you're going to put 100. And then stick it in the calculator. This is a listening check. Underline the word linear under quadratic. Then get 25. Now they want you to explain what that means. What that means is after, remember X is the number of time you spoke in minutes. So after talking for 100 minutes, you have $25 left on your phone. All right, second question is find the value of X. Find the value of X that makes f of X equals 10. So you write f of X equals 10, write the equation which is f of X equals all of that. And now they're telling you f of X is equal to 10. So when you see f of X, you're going to put 10. Solve the equation. So take the 40 to the other side, it's going to become minus 40. So it's going to get me negative 30 equals negative 0.15x. Divide both sides by negative 0.15. And you're going to get x is equal to 200. This is a listening check. Color in the 0 and the 40 in the table. Right, so they're asking you, what does it mean? Well, x, remember, is the number of minutes, right? F of x is the dollars left after you've talked, right? So you're saying she would have used 200 minutes when there was $10 left in her phone. She would have used 200 minutes when there was $10 left in her. This is a listening check. Color in the two f of x's that are circled.
I bet you just wanna let your light shine.
All right, final example. All right, during World War II, militaries were fired from the trenches 3 feet down. And remember, I initially copied my exponential and quadratic wrong. That's why you see it's white out now. But what does it mean? Anytime you see velocity, gravity, it has to deal with quadratics. Okay, anytime you see that. All right, so if it has to deal with anything with air, speed, anything like that, it's quadratics. And they'll never make you write the equation, so that's all you really need to know, that it's quadratic. If you see anything that's tripling, halfling, doubling, that's exponential. And it's really, you always have to write the ratio and multiply. If you see anything that's going at a constant rate, if you're adding or subtracting a constant number, that's linear. And that's pretty much it. Let's practice.